All right, let's get started. Well, thanks for coming. This is a session on exploring collectors. And I want to talk about this one utility class that's in the JDK that's been a fascination for me ever since I ran into it in Java 8. Not only is it a very fascinating class in the JDK, it's one of those classes that has had some methods being added in almost every single release of Java since Java 8. And every time there's a release of Java 8, I'm curious to know what new methods are available. And this has been growing, but it's pretty complex already. Well, rather than using the word complex, I'm going to say it's pretty capable already. There is quite a few things we can do with it. But at the same time, though, it becomes a bit of a challenge if we don't really understand what we can do with it. And that's what I want to do in today's presentation is talk about collectors, talk about why we need to use collectors and how we can use it, and then talk about a bit of a recursive nature of collectors, and I'll get into that a little bit later. If you do have a questions or a comment, fire away. I'd be delighted to hear from you. Just draw my attention. Even if I'm looking in your direction, if I'm not responding, that usually means my mind is zoned out and thinking about something else. But just draw my attention, wave at me, make some noise. I'll be glad to hear if you have anything to say, and I'll be delighted to respond to it. So let's talk a little bit about Java itself. I was absolutely blown away with Java's functional programming capabilities, and partly the reason for that is I came from the background of using other languages. I program in about 15 different languages, and I have been fascinated about languages like Groovy and Scala and Erlang and Ruby and so many other languages. And in all honesty, I'll admit, when I came to know that Java is going to have lambdas, I said to myself, what's the big deal? I just don't care. Because I've done lambdas in other languages, why should I care about it? And I remember distinctively standing up at my desk, looking at the Streams API, and I was convinced. And the reason was that the Streams API gave us the ability to do lazy evaluation. And to me, functional programming really is two parts. Functional programming is a functional composition plus the use of lazy evaluation. Without lazy evaluation, all we get is cute syntax, and that's not going to really excite me. But Java really brought to the table the power of functional programming in terms of lazy evaluation and at the same time also the functional composition. So I was convinced that this was going to be really useful and good, and I started diving into the functional programming APIs of Java at the time, and I was back programming in Java because of that one single reason, among a few other things as well. But then, of course, in functional programming, we typically have at least three fundamental functions that we often use: the filter, the map, and the reduce functions. And the reduce function is really where we may take a collection of data and reduce it or boil it down to a single value. But it doesn't have to be a single value in a sense. So one of the ways I look at reduce is, think of a reduce as going from a stream to a non-stream. So if you're dealing with a stream, a filter takes a stream and gives you back a stream. A map takes a stream and gives you back a stream. Reduce, on the other hand, will take a stream but will give you a non-stream. That could be a single result, could be a list, could be a set, but anything but a stream. So that's a termination of a stream. That's what a reduce really is. So naively, we can think of a reduce as a single value, but in a sense, it doesn't have to be. And reduce also comes in multiple different forms. So for example, a sum operation is a reduce operation. A min or a max is a reduce operation. But in more general term, in Java, when we use the word collect, collect is a reduce operation as well. And that is something we need to keep in mind, that collect is actually a reduce operation. Well, it's no surprise that the collectors is really has the name, part of the name as collect, and the reason for that is a collector is used as a utility when it comes to collecting. So this is all about reducing. That's what it is. This entire scheme of operations is to reduce a stream into something much more concrete. That's what it is for. Let's examine this really a little bit. But before we do, I want to emphasize one thing we need to keep in mind when it comes to programming in the functional style in Java. And that is, the functions have to be pure. So what is a pure function? A pure function is a function that does not have any side effects. Now, when it comes to side effects, we often grasp very quickly and we say, aha, if your function is modifying something, that's mutating something, that's a side effect. But it's important to keep in mind that for a function to be pure, there are two rules we have to follow. One is the function doesn't change anything. Of course, everybody knows that, everybody kind of figures that out very quickly. But the other thing that's extremely essential is the function does not depend on something that may possibly change. And that is extremely important to keep in mind as well. So a pure function doesn't change anything, but it also doesn't depend on something that may possibly change. And that kind of functional purity is very important. Now, the downside is when you program in a language like Haskell or a purely functional programming language, you cannot possibly do this because the language will prevent you from writing impure functions when it comes to using lambdas. On the other hand, Java is a hybrid language. The functional nature has been bolted onto Java. So it's your responsibility, it's my responsibility, our collective responsibility as programmers to make sure the functions we are writing is pure. And if we don't follow that, really bad things can happen. The compiler will not tell you you are wrong. Eventually, you'll figure out things are wrong when the code begins to misbehave. But of course, you know one thing about code misbehaving. It never misbehaves in your terms. It always misbehaves when you do that important demo to that important client, isn't it? That's why we have to be very careful about it. So having said that, let's talk a little bit about avoiding this impurity. But one thing clearly we need to be careful about is to prevent a shared mutability. Now, sharing is a good thing. Remember what mom told us, we should really share. Well, mutability is something we have done in Java for a long time, so we don't really think about it too much. But shared mutability is devil's work. And the minute we bring shared mutability, all kinds of things go wrong. We have to be careful. Well, enough talking. Let's take a look at some examples and play with it. So I'm going to start with a really small example and build on something that looks really nice and reasonable. What could possibly go wrong here? So let's talk about taking a list of integer values to begin with. We'll call it numbers over here. And I'm going to simply say list of using Java 9, a beautiful feature of function. And there's going to be a list of numbers, let's say 1 to 10. And what I want to do is to print, let's say, the double of all even numbers in this given collection. Now, that seems to be a very simple problem. We can use a functional style to implement this rather than the imperative style. So what am I going to do? I'm going to say numbers.stream. So a stream, as you know, is an internal iterator. And the internal iterator gives us the possibility to iterate over a collection of data very nicely without having to really worry about the iteration itself. So you keep your focus on what to do per element without getting dragged into how to perform the iteration itself. So then you say .filter, and given an element mod 2 is equal to 0, there's your even numbers. And then I perform a map operation, give me the double of those values, and then for every single value given in the collection, I want to simply output the value given to us. So when you run this code, you can see it gave us the double of all the even numbers in this collection, so that was very easy to write it. So this becomes a nice functional pipeline, and of course the lazy evaluation is embedded in there. Line numbers 9 and 10 do not execute until you hit the terminal operation. For each is a terminal operation, reduce and collect are terminal operations as well, and that's our plain run-of-the-mill functional pipeline that we are looking at. Now, this problem was fairly simple. We wrote this code, and so we are very happy with it to begin with. Now let's change the problem just a little bit where things can go wrong. Now what I want to do is to take this problem a little further and say, store in a list the double of all even numbers. So I change the problem just a little bit. And so what am I going to do? I am going to go ahead and write this code. And first of all, I say list of integer. We'll call it double of even. So we'll call it double of even is equal to new array list. And we create an empty array list. What we want to do in the very end is output the double of even numbers. Then what do? Everything goes fine until one point where We come in here, and then we suddenly say over here, double of even.add, and add the element to it. Now, before you try to take a photo of it, let me say, don't do this. We live in a dangerous world today. I write a stupid code and say it's wrong. Somebody takes a photo, tweets it, and 10,000 people call me stupid after that. So it's better to always qualify it. Now take all the photo you want to take of it. And so the point really is don't do this. Now, why shouldn't we do this? Now, this is the scary part about this function. I come across somebody writing this code, I'm not even kidding with you, every single week. Now, what was even more scary is it was the week of the holidays, and so nobody had to email me. And I was thinking, gosh, this is 1 week finally, I don't have to see this stupid code. And you know what I was doing? I was writing code, and 15 minutes later I was refactoring, and was absolutely shocked because I had written that code myself. And I just told myself I didn't do this, aliens did this, right? Because I know not to do it, but this is so compelling we simply do it out of not even thinking. But this is a bad code I have written, I've seen other people write it. But the funniest email I get is this. The email always starts with, this code worked fine until yesterday. And then the person writing the code would tell me, I took this code, I made it parallel, and nothing works anymore. I usually don't even read the remainder of email. I quickly go to the code, look at the for each, and say, there's your problem right there. Well, the problem with this code is that this code can never be parallelized. Why is it so? Because right there on the line where we say don't do this is what is called the shared mutability. And so shared mutability is absolutely evil, but where is the shared mutability in this example? Now imagine if I were to take that stream and turn it to a parallel stream, what's going to happen? Well, this is going to run in multiple threads at this point. And when multiple threads run, when it comes to the for each method, all these multiple threads are going to attack that particular double of even and try to add it. Now, what would possibly go wrong? And that's the beauty of it. It's completely unpredictable. And most of the time, it may give you the correct result. And you can never say the code worked when you look at a code. In fact, I quit saying the word code worked. I always say the code behaved. That's all I can say, right? Whether correctness or not is a completely different story. So the point really in this case is, if you ever turn this code into parallel, the results will be really bad. And like I said, this is exactly the emails I've gotten from people who show me a code for their own domain, for their own application, and they drop me an email and say, look, this code worked yesterday, but I really wanted to make it parallel, so I made it parallel. It doesn't work anymore. Why? Well, the reason is the Java compiler doesn't protect us at this point, but the function on line 13 is not pure because it is performing a side effect. It is changing a state outside. So what is the right way to write this code? Well, the right way to write this, oh yes, please. So the question is, what if the list is a concurrent list? That's a really good question. Now, the question you want to ask is, do you really want to limit the concurrency that way, right? Because there's a very easy way to solve the problem, and also it becomes very error prone. You are sitting on a ticking time bomb, right? That becomes a concurrent list, really point well made, but tomorrow somebody refactors it to a non-concurrent list, and there's a ticking time bomb sitting in the code, we won't even know that. And so it's better to eliminate these things from the get-go rather than designing it that way, because we don't need to. So one of the things I've learned in my life is the more code we write, the more we have to maintain it. And hands down, the code I did not write has the fewest bugs in it. So as a result, if I can reuse the library of function available, I'm much better. And the reason is the people who wrote that library took a lot of time and effort to make sure it's correct. I can never compete with that. Instead, I can focus on my domain and rely upon the infrastructure to write the code I'm going to use. So what is the better way to do this? I won't go into that detail here, but one way you can do that is you can change this code into a reduce function. And if you change it to a reduce function, that code is going to become a monster. And I usually do this when I teach a course on Java 8. I usually take this point and I change it to a reduce function. I show how that works, and people look at it and say, okay, that makes sense. My God, this is a monster. Should I have to write it? And then I often say, no, we don't have to write that monster. It's written for us already. That's what collectors are. So given the short amount of time we have, I'll just kind of bypass that. So what is a better way to write this code? A better way to write this code is really to say collect. And when you say the collect method right in here, the collect is going to be a reduce function, that's what it is, but what are you going to collect it into? It's kind of funny that you're passing a list, two list functions output to the collect method. Well, the reason is the collect method takes as an argument a collector. So a collector is just a class, it's a higher level class, higher order function, which is going to allow you to perform the collection in a sensible way. So if you had written a function to reduce, you would have taken the effort to eventually come down to what the toList method is doing for you. So where's the toList method coming from? You go to the collectors API, and that is part of the java.util.stream.collectors. And there are a number of methods in this particular class, and they're extremely useful for what we want to really do. So by doing this, what did we do? Now when I run the code in this particular case, what it's going to do is to take all these values that we provide in here, and then of course I can simply put that into this collection. So the beauty is we don't have to create that silly empty collection to begin with either, and as a result it becomes a nice output at that point. So you can simply call the collect to list and then put that value into the stream and be done with it. So let's get rid of that code, ugly code we shouldn't be writing, and the toList function works like charmingly well. But the nice thing about the toList function is it is written in a way to take care of concurrency. To her point earlier, rather than we trying to solve the problem, we rely upon a thread safe method that's already available. The people who wrote the toList method have taken care to make sure it can handle concurrency fairly well. So if I don't have to worry about refactoring the code and losing that and introducing errors in my code. So the toList method does that for us already. So that is basically the way to really do this, is to depend on the collectors function, and this is a static method. Sometimes people import the collector only, and then they simply come down here and say collectors dot, and that's perfectly fine, nothing wrong with it. I just prefer to really use it as a static method, but your mileage may vary. You can do whatever that makes sense to your coding standards. So that is basically bringing in the toList method. So we looked at the toList function right there. So that's a better way, a right way to really do this, is that you want to really leave it to the APIs that you can use rather than taking that on our hand. Much like this, you can not only create a list, you can create a set as well. So for example, in this case, when I ran this code, let's actually rewrite this code a little bit differently. I just want to output the result of that right in there. So when I execute this code, look at the output 4, 8, 12, 16, and 20. That's what we got for the toList function. But I can change this to a toSet function. Now we know something about sets. One is that the elements are distinctive, and second, we know that sets don't guarantee any ordering of the elements. So when I run this code, notice it provided 16 for 20. That is because sets don't guarantee ordering. So even though the input collection was ordered, the output set was not ordered. That's what you're basically seeing in this example. So you can convert it to a list or to a set or whatever that may make sense to you, depending on your situation. You can really do this. Now, that's great so far. And if you stop at Java 8, that's all you're going to get. But on the other hand, you say, wait a minute, you talked about immutability and purity of functions. Shouldn't we really be honoring this a little bit more? So to answer that question, if I take a double of, let's say double of even is equal to, and store this into a double of even, and then once I store it, I'm going to come in here and output double of even. So when I run this code, what is it going to do? It is going to give me the list of these elements, obviously, and you can see this output. Now, this is great, no problem with it. But one of the problems is, what are you going to do with the double of even at this point? Well, what if you're not just printing it out? What if you're going to take this and send it off to another method if you really wanted to? What would you do? Well, in that case, you may want to really make sure that this is immutable. Well, I'm going to actually make a little change to it just to illustrate this point. So if I were to go to the double of even and add, let's say, a 7, you can see in the output the 7 is sitting in there, which is probably not what we really want. We really want immutability on it. So what can we do? Well, moving forward, this is in Java 10 and later, what you can do is you can say to unmodifiable list. So by asking for an unmodifiable list, you are telling that the list that is created should not be mutable at that point. So as a result, in this case, if you look at the line number 13, when I run it, it fails unsupported operation exception, and that is because the unmodifiable list is creating, obviously, as the name indicates, a list that is not modifiable. So if you really want the safety at that point, rather than using toList, you can use two unmodifiable lists. Instead of using toSet, you can use two unmodifiable set. Similarly, instead of toMap, you can use two unmodifiable map as well, and you can just get a little bit more protection by making it immutable. So that's something I would really recommend doing. So with that said, let's talk about one more thing before we go any further. I'm going to swap this a little bit because it's easy to build on this example. Well, one of the things you can also do while you're at this is, there are times when you take a particular set of data, but you want to really split that into two parts. For example, you might want to take the numbers given, and maybe you want to deal with even numbers separately from the odd numbers. Now, one of the nice things about filter is, a filter is like a coin sorter. A filter will let some values go through and will throw away other values. So if I filter for even, I get even numbers, but I don't get the odd numbers. If I filter for odd numbers, I get the odd numbers, I don't get the even numbers. Now, what is even worse is, if I want both of those, I have to run through the iteration twice, which is very smelly. Obviously, we don't want to do that. Why would you want to iterate twice on a collection? Well, this is where some really nice functions come in to help us. So what I'm going to do here in this example is, I'm going to simply say numbers.stream, but then I call the collect method, and to the collect method, I'm going to call the partition by. And partition by is going to take a predicate. And just like a filter takes a predicate, a partition by takes a predicate. And what am I going to say here? Given a number, give me a partition on even versus odd numbers. Now, this could be full-time employees versus part-time employees. Could be in-state employees versus out-of-state employees. Whatever that could be, depending on your domain and application. Qualified versus non-qualified. Whatever that could be, right? You can decide that. So when I run this code, what does it provide for me? A partitioning by. So it does require us to spell these things properly. And so at this point, it does give us the false versus true as the two different partitions, as you can see in this case. So the false, of course, is the ones that are not even, and the trues are, of course, the ones that are even. So in this example, if you have employees, you can get a partitioning of full-time employees in one side and part-time employees on the other side, or taxable versus non-taxable items in your store. I mean, you can take this to any extreme depending on what you're trying to do in your domain. And this is what a favorite method for me is, it immediately allows me to partition a given collection based on these two in one single iteration. Now, what you also notice over here is that how collectors give you this beautiful higher level of abstraction. You're going to take more time to think about it. You're going to take more time to learn it, but then you write very little code. And the benefit of that, of course, is you don't have to sit there and write a lot of verbose code to maintain. And once you understand how things work, it reduces the time that it takes, and we can just write more code more effectively. That's a benefit you get out of this. So that is the partitioning by function that you can use. I'll come back and talk about a few more things about this in a few minutes, but let's switch gears to a slightly different example that will help me to get through the other functions. We looked at fairly simple things, but let's take this a little bit to the next level. So what I have here is a collection of people. So I have people with same names, I have people with the same age as well that they are sharing. So we have Sarahs and we have Jacks, we have people who are 20 years old and so on. But what I want to do is to work with this group of values. So one of the things that's given to me here is, given the names, let's say, print all names in uppercase, well, all names, let's say, of length, let's say, 4, comma, in uppercase, and I want to, and of course, a comma separated. Now, one of the things to really think about is you want to be able to write code, very easily, And simple code should be simple and complex code should be really manageable. Now, when you look at a problem like this, you say, gosh, this is not rocket science. I should be able to do really quickly. So what are we going to do? We could write the code in the imperative style. We could say for a person, and we could start iterating over the person. And then you could get whether the person has a name which is for letters long, and then you could convert to uppercase. But then what you notice very quickly is there is a stupid comma in the very end when you print it. And what do you do with that comma in the very end? I mean, this is a problem every one of us has faced, isn't it? And the first time you face it, you're in denial. You tell yourselves, this cannot be happening to me. This is such a stupid problem. Why is it so hard to solve it? And the more code you write, the more frustrating it becomes. And I often think about coding this way. Sometimes coding feels like violence. If it doesn't work, do more of it, right? And that is not a good way to do anything. We need to be really gentle. We want to reduce it. So what can we do? Well, this is where the collector has one other very useful function. So what we can do is output again, and let's start with a list of people to begin with. We'll say person people is equal to create people. Oh, by the way, you probably know this already, but a person has a name, person has an age, so obviously you would expect a get name function, get age function. That's just a POJO, that's what it is. We don't need to look into it. So what am I going to do now? I say people.stream, then I say filter. And what am I going to filter? Well, first of all, I want to get the name of the person, isn't it? So map, and I'm going to say person get name. So we got the name of the person on our hand. Then I say map again, I say string get to uppercase. So we convert the names to uppercase nicely. So now that we got the name in uppercase, we can do a filter. And if you really insist, you could do the filter before this also. So given a name.length is equal to 4, and we have done the transformation at this point, then what are we going to do? Simply do a collect at this point, and then simply say joining, and join with a little comma. That's what we really want to do, is join with a comma. And of course, the good thing about this is there's no stupid comma in the end. So this gives a nice way to perform the transformation and perform the joining. In this particular example, the filter can be one line above or one line below the map. It doesn't really matter. So you could go either way with this. In other examples, that might not be the case. We got to be careful where we put the filter on the map in general. So that gives us an idea about how we can use the joining function. Again, that's a reduce operation, and joining is part of a collectors API. So as you can see, where does the joining come from? Well, that comes from the collectors as well in a sense. So that's what you're using here, the joining function. Well, that's great so far. We looked at the joining and how we can make use of it. But let's take this problem a little bit up further. So we have names given to us. And imagine, now you have names like Sarah and Bob and Paula and Jack, but I want to collect all my friends with the same name together in a group. So I want Sarah's to be together. I want Jack's to be together. So what am I really looking at? I want to create a map of a string for the name. And what is the value going to be? It's going to be a list of person. Does that make sense? So given a name Sarah, I want both the Sarahs as a value for the key. Given a name Jack, I want both the Jacks as value for the key. Given Bob, of course, Bob is the only one in that particular thing. So I'm going to say by name is equal to new hash map, and we can create this. Now imagine writing this function using the imperative style. Now this can be a really nice competition to have at work. If you have somebody who doesn't believe in functional programming, give them this problem. And while they are writing the code, you can go eat their lunch. And that is the nice part about this, isn't it? Because I want to imagine how we would write the code, because I don't have the guts to write that code here, but who wants to? So what do? You take an first name. Oh, Sarah. Do we have Sarah in the map? Oh, we don't. Let's create a list which is empty. Insert that list into the map and insert the object person Sarah into the list. Next one, oh, that's Sarah. Do we have Sarah in the list? Look what we found. Let's get the value. Let's take the list. Let's append to it. Who wants to write that code? Yeah, he's already yawning at this point, right? He didn't even see the code. So I feel you, brother. That's exactly how I feel about that code as well. We don't want to be doing that. So wouldn't it be so cool that we don't have to write such a verbose code? We can be very highly expressive. enters a beautiful function which is called the grouping function. So grouping is amazing. So before we talk about grouping, let's conceptualize this so it becomes easy to understand. So think of having buckets in front of you. And when I see a name, I'm going to create a bucket called the Sarah bucket. And I'm going to put the person Sarah in that bucket. And the second person is Sarah, goes into the same bucket. The third person is Bob, create a new bucket and send Bob to the second bucket. So think of these as buckets. So grouping by simply creates buckets. If a bucket exists, it puts the object in the existing bucket. If the bucket doesn't exist, it creates a new bucket. And that's exactly, once you conceptualize this as buckets, it becomes easy to understand what grouping by is doing. So let's look at how we can use grouping by for this purpose. So I'm going to remove that part right there, and I'm going to say by name, and then I'm going to simply over here say that people.stream, and then I say dot and collect one more time. And then when we are done with it, we'll output right here the by name so we can take a look at it. So what is the collect going to do at this point? Well, the collect is going to do the following. It says grouping, so grouping by, and what am I going to group based on? Given a person.getName. So this is the one that tells you which bucket to put into. So the parameter you pass to the grouping by tells you what bucket you want to be in. I want to be in the Sarah bucket, I want to be in the Bob bucket, I want to be in the Jack bucket, whatever that you want to be. So if I run this code right in here, notice we have Bob and the person Bob, we have Sarah and the two Sarahs, we have Jill and the Jill, and Jack, and of course runs off the screen, but you get the point. So that's, we have grouped it based on the names at this point, so that becomes really easy. But of course there's a slight simplification you can do. You're looking at line 23 and you're thinking, oh Venkat, that is pass-through lambda, you might as well use a method reference. I absolutely go for that refactoring. So I can take this one and say person :get name, and you can simplify that very nicely, and as a result you don't have to write a verbose code as well, so that becomes very expressive, as you can see. So that becomes a collect grouping by name, so that becomes very fluent. So you're saying given a people collection, collect them by grouping based on the name. Look at how expressive that is. The code begins to read like the problem statement without having to deal with, let me figure out what the code is doing. And compared to the imperative style code, this becomes a lot more easier to work with. So that is the grouping by. Now, until this point, we always were passing one function to collect. You saw me call joining, you saw toList, toSet, Unmodifiable List, you saw me call grouping. Now we are going to take this to the next level of power. Now the next one is a mapping function. Before we talk about it, let's see what problem we want to achieve. I don't want the people in my collection. I don't want the Sarahs to be in my list. I don't want the Bobs or the Jacks to be in my list. What I want in my list is just their ages. So I want to know what the ages of Sarahs are. I want to know what the ages of my friends Jacks are, and so on. And I want to be able to find that information. So if that is the case, what is this going to be? It's not going to be a list of person. It's going to be a list of integer. I was giving this talk and somebody protested and said, I disagree. I said, what's up? And they said, it's got to be a list of long. I mean, I understand the sentiment. But the point really is that these are age values and integer values. I just want a list of integer values. That's what I want here. How do I get that? Well, if you think about it, what does that mean to get the age? Oh, given a person, I want the person's age. Well, what is that? Well, if I were to just do this in a filter and map, you would be doing a map function. But there is one problem though. If you do the map and take the person and get the age, you have the age on your hand, but you don't have the name anymore. Oh, darn it, I want name and age, so it's a little too early to perform the mapping. Well, one thing you could try to solve this problem with is, you could do a map and you can create a tuple. Oh, but wait a minute, Java doesn't have a tuple. Well, you can create your own data structure that carries name and the age, but then you realize, that's all great, but nothing looks really happy, isn't it? Well, okay, I want to map, but I don't want to map yet. I want to map after I group. Aha! So here's what I want to do. Right before I throw this object into the bucket, what if I can do the mapping? That's exactly what we're going to do. So you first group it, you decide which bucket to put into, and right before you throw the person into the bucket, perform the mapping and throw the age and leave the person alone. So that's exactly what we're going to do. And once you understand that, it's a question of figuring out the syntax. So I'm going to say, in this case, comma, and notice where I put the comma. That becomes the second argument to grouping by. And this blew my mind, I'll tell you why. Because this is a recursive structure. A collector can be created with another collector, which can be created using another collector. The 3 dots I put the ellipses, that's going to be a collector. And that collector, well, okay, thank you for that. So this part of the program is sponsored by Docker. Okay, so sorry about that. So right there, you can see that it is actually, that's how you lose your chain of thought. Okay, so in this particular case, you can see that 3 dots are going to give you the collector. And using that collector, you can build bigger collector, which is the grouping by, which you then send to the collect function. So what do? I'm going to say mapping. And what am I going to map in this case? Given a person, get me the age of the person. And then what do you want to put it into? To a list. And you call the toList at the very end of that. Let me just put that on the separate line so it's a little easier to see, and make sure it's working before you take a photo of it. So there you go. So what it really gives you is that you have the get name, but then you say, before you throw this object into the bucket, do a map operation. So this is a late mapping rather than early mapping. Had you done the mapping in the functional chain right after stream, you have to carry the name and the age with you. That's a burden you have to carry. Instead you say, never mind, I'll postpone the mapping. That's exactly why it's called mapping. So you postpone the mapping and you do the mapping after you do the grouping. And this can be taken to, hopefully not too extreme, but multiple levels based on what you're trying to do. So that gives you an idea about how you can map it. Now, on the other hand, well, that's great, but what I really want is not a mapping, but what I really want is the number of people with a certain name. Now, this is a fun exercise to have. Of all your friends in the world, think about what's a common name of your friends. Friend names are overloaded. I just one day woke up and realized that I have the most number of friends with the name Brian. I don't know why, right? And so Brian wins, right? Brian's win. And I don't know why I have many friends whose name is Brian. If anybody's name is Brian in this room? You're my friend too. Absolutely. Now you have a new friend now. So the point really is that you can maybe want to do this little exercise and find out what's the most number of friends of a certain name you have. But how do I do that? How do I know that? Well, what you can do then is you can go back over here and you got the names, but before you throw that into the bucket, you can perform another collection or another reduction rather. So what you can do is you can say counting right there, and you are counting it, and then you're asking it to, okay, this is one more parenthesis than Lisp allows. Okay, so right there, so you can see Bob, there's one Bob, there's 2 Sarahs, there's 1 Jill, there's 2 Jacks, and you can see how that was able to bring that in. So that is an example of using the counting function, and look at the power of it, right? It becomes really easy. Your group, again, I want you to think about this bucket concept I talked about, because that helped me to understand this better. So just because before I throw that into the bucket, what do I want to do? Oh, I want to perform a mapping, I want to do a counting, and stuff like that. So this is counting it, which is itself a reduce operation, and then you're putting it into the bucket, and that becomes a lot easier to work with. So we saw how to perform the counting, but you notice this and say, aha, but I noticed one thing you did quietly over there without saying it. You quietly changed the long integer to long to the integer to the long, and the list of integer to the long in fact, right? So integer. But what if I really wanted an integer? Well, sad news is counting actually gives you a long, and so that code fails, and it gives you all kinds of error, which is kind of scary to look at. But if you want to really deal with it, you actually can. This can be a really nice exercise for a Friday afternoon, and this is a nice way for teams to learn, and you can say, give this problem and say, how do you make this an integer? And you will have teams of people coming up with different solutions, which is good, that's the way we learn. But then what we realize is, you can do something a little different. What you can do is you can say, go ahead and perform the grouping, and then you can say over here, use this function which is called collecting and then. So collecting and then gives you yet another operation to perform moving forward. And so collecting and then, and what do I want to do? I want to do counting, all right, but then I want to say long and get the int value out of it. So this gives you an opportunity to get the value, but you can also perform yet another transformation. Again, this is one specific example, but I want you to think about the collecting and then for a minute. So it gives you a breather at the point and saying, all right, I finished the collecting, but I'm not done yet, and I want to do more after collecting. And so this gives you an extension point to go collect and do some more before you finish your final collection. So this can be really powerful. I do have to say that this is a little complex. It kind of hurts my head when I look at it, but stare at it for a few minutes, it goes away. So the thing is that to really understand how this can be used, so this is a collecting and then how you're able to go ahead and got it, thank you. So collecting, and you're able to go through this quite a bit, and you're able to just build on it very nicely. So that gives you an idea about how you are able to build on this to move forward, and you can just build upon this collection quite effectively. So with that said, we saw the collecting and then, and this gives you the hierarchical nature of what we did quite effectively, and this becomes a nice buildup of the transformations. So summarize what we talked about here. What you're looking at is a collect is a reduce operation. Well, the collect being a reduce operation, you want to make sure it's thread safe as well. So you want to be able to parallelize this code if you want to really. And how do you really make this in a thread safe manner? Well, one of the ways to do that is to rely upon a library of functions that can do that for you. Collectors not only give you that thread safe library of functions, it also gives you higher level of abstraction. So as a result, you're able to build upon these things a series of transformation. And so if you're sitting down with a problem at hand where you have a collection of data and you want to be able to take and manipulate it, the chances are you'll find a solution by putting a combination of collectors. This has been a really good exercise for me to try because rather than sitting and writing verbose imperative code, I would think about this, scratch my head a little bit, and play with a few collectors. And this is one of the reasons why I'm also a huge fan of automated testing. So normally what I do when I work with the team is I have this mantra that I follow, and the mantra is make it work, make it better real soon. And make it work, make it better real soon is when they're writing the code, I often tell them, don't worry about it, don't try to make it pretty, don't try to make it concise, just write the test and write the code. And once the test is passing and we know that's what we want the code to do, we'll come back and take a stab at it and refactor it. And another thing that excites me about this is when I make a suggestion, why don't we try this? The worst suggestion is a suggestion that doesn't work. And people lose faith in what you say. But the fact that I have automated tests, I often say, why don't we try it? But I know it actually works because the tests are passing after the change, or it doesn't, and I quietly back away from the suggestion and think of something else. So this gives us the agility for us to try out and experiment, and then we can apply that learning quite a bit as we move forward. So collectors have been a really charm for me. This is one of the APIs I really like. Like I mentioned, every single release of Java. Yes, please, go ahead.
So I know this is some of the videos I've seen of you doing RX Java. With Java 8 and all the features we have with functional interfaces and lambdas and all that, would you still recommend using RX Java alongside?
Yeah, so I'll answer that very quickly, but we can definitely take more offline if you want to talk about more. So to me, RX Java is great when you really want to go across processes. And Streams API is still absolutely sensible if you're within a single process, a single JVM. And it's native to JDK, so you don't want to really use an external library in a lot of different situations. So we need to really decide based on the context of what we are dealing with. So that's basically about collections. If you're interested in downloading the code examples, I will post that later today. So if you go back there to my site tonight, you should be able to find the examples I wrote here. Hope that was useful. Thanks for coming.